Hi viewers, today we will discuss translation in graphs. Before that, you know the use of translation in transformation. So where the basic idea of translation is the movement of an object along x-axis, right, left, up or down. So here we will discuss how to use translation concept with the help of translation vector. So we will see when we have given function. As you can see here, we have few rules that will help you to find out the translation in graphs along x-axis or y-axis. So when we have a function, as you can see that this is first rule, y is equal to f of x. This is a normal curve. It can be a cubic curve or parabola or different curves like hyperbola, ellipse. So when this curves becomes f of x, y is equal to f of x plus a, it means this is translation in the y-axis and the translation vector is 0, a. And if it is f of x minus a, then still it is translation in y-axis but towards down, means 0 minus a. Same as two rules are here. As you can see that the graph of y is equal to f of x minus a is a translation of graph of y is equal to f of x by this translation vector. Remember that in the x-axis translation always opposite to the translation vector, means if you have y is equal to f of x and the translation of this given function is f of x minus a, then it is along x-axis but opposite side, and over translation vector is a 0. And the second thing, if you have y is equal to f of x plus a, that means still this is translation along x-axis but opposite to the plus a, means your translation vector will be minus a 0. And sometimes we have a translation along x and y both, that we will discuss later on. So first we will see how to utilize these translations in graphs. For example, here we have one question: y is equal to f of x has a maximum point 0 0, which you can see that it's n shape, means y is equal to minus x squared, but they have just mentioned only y is equal to f of x is a curve, and our goal is to find translation here. Okay, find the coordinate of the maximum point. After applying this translation, what is your new maximum point? So we already know that if we have f of x, y is equal to f of x, and now y is equal to f of x plus 3. So this is translation in y-axis, and translation vector is 0 3, means 3 unit up. So your new answer will be, if you check the first one, so we can say that from maximum point, look, our maximum point was what? 0 0. Fine. So after applying this translation vector, and it will affect only y element or y axis, means 0 comma 3. This is your new element or maximum point after translation. Okay, so 3 units straight away up from the maximum point. So 1 2 3, this is the point, and rest you can check 2 more so that it is easy for us. For example, this point is exactly 2 and minus 4 down. So we have to go up straight away 3 unit, means minus 4 plus 3, that gives me minus 1. So means my new point will be 2 comma minus 1. So straight away up, x-axis will not change. Okay, 1 2 3, this one. this point, and same as if you want to check from this side. So 1, 2, 3. So your new curve will be, you have to just connect. It's better we change the color like this. It's coming like that. They are just asking only the coordinates, but I found or I showed you on the graph paper its situation is what. I hope so you understand. We just move 3 unit up of the original graph from each coordinates. Okay. Now we move on next part B. And in B part, what they say, if we check carefully, this is also translation along y-axis. Y is equal to f of x, and now y is equal to f of x minus 2. So this is translation in y-axis, and translation vector is 0 minus 2, means it is 2 unit down. So you can check in the same or the next, it's up to you. For example, if you want to check here, we have 0 0 from straight away 2 unit down. Okay. Let's suppose our maximum point is 0 0, and now once you apply this translation vector, this will affect on y elements. That means 0 comma minus 2. So if you check 0 minus 2, that would be here exactly, and we can check the others also. For example, this point is exactly 1 minus 1, so this can be 1. If we have 1 minus 1 and we are adding minus 2, so it would be 1 minus 3, means 2 unit down. Okay, so 1 1 2 3, it is here. Same as if you check minus 1 and minus 1, so this is here. So I hope so your curve is moving like that. New curve moves like that, like that. So 3 unit down. Okay, sorry, 2 unit down. Now next one we will try along x-axis transformation, see how to uh, apply the concept. For example, if I check C part, then we have original function is y is equal to f of x, and now we have y is equal to f of x minus 3. So this is translation along x-axis, translation along x axis, and our translation vector is, remember that be very careful with the signs that they are opposite to what most people expect. So this is always opposite. For example, here you have x minus 3, so my translation vector is 3 0. And of course the first, basically they are writing in column vectors, and first element belongs to x and second element belongs to y. So if I check in the first, means now remember that our maximum point was what? If you check carefully, our maximum point was 0 comma 0, and now after applying this translation vector, it would be 3 comma 0, means 3 unit right. 1 2 3. So it will bend from this point. Okay, this is your maximum new point, and each point you can move 3 unit right. For example, this point is 2 minus 4, so we will add into 3. Yes, so 5. 1 2 3, so it must be at 5. Yes, same as if you want to check this point, which is at minus 2. So minus 2, basically it is minus 2 and minus 4. So we are applying on x-axis, means effect will come on an x-axis. So minus 2 plus 3 gives us 1. 1 minus 4 means 1 minus 4. So straight away 1 2 3 here. Here you will find 1 minus 4, and then just you connect. This is your new curve. I hope so you get it. This is the translation in the x-axis with translation vector 3 0. Same as we can try the last one and see how to solve the last one. Last one we have y is equal to f of x, and now y is equal to f of x plus 2. So we know that this is translation. This is translation in x-axis, and the translation vector is, remember that opposite of this sign, okay? So -2 0. So once you apply, over maximum point is 0 0, and by applying this translation vector, it would be -2 0, means your new point is -2 0 here. After this, you can check each x value will move 2 unit left, okay? For example, this point will move 2 unit left, 1 2, and this point also 1 2. So means your new shape is like that, like that. I hope so you get it, how to apply a translation concept in graphs. We will try to solve few more questions. So here they want us only to write on the vector that translate y is equal to f of x onto by applying these functions. So I will write straight away the answers. No need to draw. Just straight away we will find out our right a part. Let's suppose our original function is y is equal to f of x, and now we are looking a part. So y is equal to f of x minus 7. So this is translation in y-axis, translation in y-axis, and the translation vector is what they want, that is 0 minus 7. And if we try b part, this was a, we have original function y is equal to f of x. Now y is equal to f of x minus 7. So this is translation in x-axis, and the translation vector is, remember that we always take the opposite sign. So here we have minus, so we will write plus 7 0. And if we check the next one, which is c part, y is equal to f of x, and now y is equal to f of x plus 7. So this is translation in y-axis, and our translation vector is 0 7. And lastly we have d part, that is in general y is equal to f of x, and now the given function is y is equal to f of x plus 7. And we can say that the translation in x-axis, and the translation vector is minus 7 0. I hope so you understand. We move on next. We will solve few more questions. See, in this situation, I little bit try to bring little harder questions, and I hope so it's manageable. And one more thing which I was going to say in the start of the video, that once translation on both combinedly, like along x-axis as well as along y-axis. So you will find the general form like that: graph of y is equal to f of x minus a plus b is a translation of the graph y is equal to f of x by the vector ab. Before that we were checking only along y-axis or x-axis, but now both together. So how this will affect in the equations? For example, find the equation of each of the graph given transformation. So we know these are the translations. So in A part is only translation along y-axis, okay? We can say that this is translation in y-axis only, and this will affect y is equal to 2x squared plus 4 only. Because translation vector is given, so we have to apply only. Okay, this is your new equation, or we are looking the equations of the graph, new equation. After applying this translation, what is your new equation? So here, if we check this question, uh, as you can see that this is translation in the x-axis. Okay, so we can say that this is translation in x-axis, and translation vector is given, and remember that this is always opposite sign. Okay, so your original function is or will become 2 over x. Look, here we have minus 5, so I will supposed to say that plus 5. This is your new equation. And if you check this one, here we have still translation along x-axis, translation along or in x-axis, and it will affect on the original function. But remember that we will choose the opposite sign. If it is plus 3 here, so I would say x minus 3 over x minus 3 plus 1, and the new equation is x minus 3 over x minus 2. But if you check this part, next part, if you check carefully, this is translation along both. Translation, this is, you can say that combination of translation along x-axis as well as along y-axis. So if I apply this one in the given equation, so this would be, remember that this is plus 2, so we will choose 3x minus 2 whole square and minus 2, and this plus 3 we straight away add, which is along y-axis. Okay, and your new equation will become 3 bracket open x minus 2 whole square plus 1. You can simplify more further, but it's okay. We already applied this translation, which is along x-axis as well as along y-axis. So this is the combination of x and y. I hope so you understand. Now the equations are given after transformation. We will try to find out what type of translation vector is mentioned there. Are they applied? Okay, let's see. Find the translation. Okay, which type of translation it is, along x-axis or y-axis or along both. So we will try to figure it out. If you check the first one, that is x square plus 5x minus 2, and if you check after transformation or translation, we have y is equal to x square plus 5x. So these first two terms are same, they are changing in the last one. It means 100% sure we have y translation. So now y translation, what they add in minus 2 to get to plus 2. So think about, if they add plus 4 in minus 2, so answer of this is exactly 2. It means this is translation in y-axis. So, and translation vector, what they want from us, it is 0 plus 4. If we check the next one, this one, so y is equal to x square minus 3x to the graph y is equal to x. So when they apply inside the x, it means it is in the x-axis, translation in the x-axis. So we can say that translation in x-axis, and the translation vector is, look, this is always opposite. If they add plus 1, we say minus 1 and 0, because they are not adding something here, so it means it is only along x-axis. You can check also, look, if same translation vector if you apply here, it would be like that, x plus 1 whole square minus 3 bracket of 1 x plus 1. So this is exactly same, so that's what they want from us. If we check the next one, y is equal to 5 over x square minus 3x to the graph, they translated already, and we are looking what translation vector is there. So to the graph y is equal to 5 over x minus 2, it means they have the translation along x-axis, and minus 3x plus 10, it means this is the translation along y-axis as well. So remember that if they this is translation, you can say that combination of translation or translation along x axis and y-axis both. Okay, so in this situation, we will find out what translation vector. One, we can see clearly it is -2. So first translation vector value is +2 because here they write -2. So look, if I apply here 5 over x -2 whole square minus 3 bracket open x -2, and then they write it plus 10. So what they add to get plus 10, that's what we are looking over second element. So if you check, you multiply 3 inside, so minus 3x minus minus plus 6. So if I do one more step, so 5 over x -2 whole square minus 3x, till here is okay, and then minus minus plus 6, so it means they added 4 to get 10. Yes, to get 10, it means along y-axis translation vector is 4. So then it becomes, so they added 4, and the next answer is 5 over x -2 whole square minus 3x plus 10, which is exactly same. So we found the translation vector along x and y both, combined translation vector, which is +2 and 4. I hope so you understand how to get translation vector. Now one more question, we will try to see how to solve graphically this one. We already checked, but once together. Okay, have a look. One question here. The diagram shows a graph of y is equal to f of x. Sketch the graph of each of the following functions. So first one, clearly we can see that it is translation along uh, y-axis. This is translation in y-axis, and the translation vector is 0 -4, means 4 unit down. So if you find or apply this a part here, it is straight away we can say that from each coordinate will move 4 unit down. Okay, for example, this point 1 2 3 4, it is here. This point is here, this corner. You can check like this way also. For example, this corner point is exactly -1 and 1. So -1 1. So once you apply this uh, translation vector, this will affect only the y element. So the new one would be -1, and 1 -4 gives us -3. So look, from there you go down 1. We are looking -3, so that is here. Either you count 4 units straight away down, look 1 2 3 4, or 1 -1 -3, you will find it here. And then this one 1 2 3 4, this is the point. And this one 1 2 3 4. I hope so you understand how I'm getting. You can write and then apply also. For example, this one we have 2 2. So 2 comma 2. After applying translation vector, it would be 2 comma -2, because we are adding -4. Okay, so look, 2 -2 we have here. After this, you just connect. Once you connect, you will find out new. The new one is it's better we choose different color. This one. Then so this is the answer. After this, we will check the next one, B. And if we check the B, in B we have y is equal to f of x -2. So we know this is translation in x-axis, and the translation vector is +2 0. We always choose the opposite sign. Okay, so that means the new, for example, we have one point which is, let's suppose, -3 comma we have 3. Okay, so after applying this translation vector, it would be -3 plus 2 gives us -1. So -1 comma 3. So if I check one more point like this one, which is -1 and 1 up. So by applying this vector, translation vector, we have plus 2 minus 1. So plus 2 minus 1 gives us 1. So 1 comma 3. So this way you can find, or you can straight away move to unit right, okay, in each case. For example, this one we found minus 1 and 3. So look, minus 1 is here and 3 up. Yes, 1 2 3. So means straight away 2 unit right from each corner point. It means this would be 1 2. So 1 2. This one is here, and this corner point we already found, which is 1 3 1. This one, yes, 1 3 here up. Where is this point? 1 2. And what is missing here? This one, 1 2. I think we found all, or anything is missing. This one. Okay, this point, which is exactly at the last. So 2 unit right, 1 2 here. It means your new shape will be like that. If we draw, this one, then straight away down, and then here, and then straight away forward. Yes, I hope so you get it. So everything 2 unit right. Now we will see the last one, which is along both side. So see how to solve that question. If I check the last one, this is along both, okay? For example, if I write the translation vector, this is translation along x and y both. It's a combination. So we can say that a translation vector is -1 and -5. Means this is translation vector, okay? So we will apply this one on each point. For example, we have to move 1 unit left and 5 unit down from each corner point or each coordinate. So 1 unit left and 5 unit down. 1 2 3 4 5. This is my first point. Of course, second point is here. From here, 1 unit left and 1 2 3 4 5. It's here. And this one, 1 unit left and 5 unit down. 1 2 3 4 5. This point is here. And lastly, this one, 1 unit left, and we have 5 unit down. 1 2 3 4 5. So if we draw with the help of scale, it is like that. Draw straight away. From here you go down and then up and then straight away like this. So we found the last answer by applying translation along x and y both. I hope so you understand how to apply translation in graphs, and in my next video we will try to apply the concept of reflection and stretch in graphs. See you with next